This is example 1.11 from the book, and it says the mass of a sample of iron pyrite is 1.32 kilograms, and it wants to know what its volume is. And it tells us something that, in parentheses, because who just happens to know the density of iron pyrite? And we found out that that is 4.9 grams per milliliters. So in case you, it has the unit that should make it obvious its density, but in case you get confused, you can label it. You can even label the mass. So let's start by writing our density formula. So we have density equals mass over volume. And you should have that memorized. But if your parent allows, you can have a note card on the test of formulas. All right, so in this case, we have the thing that we want to put in right here. And we have the thing that we want to put in right here. What we don't have is the volume. So the easiest way to deal with this is to go ahead and rewrite this equation. And in case you're not very good at rewriting equations, let's do this step by step. So we're going to multiply both sides by volume. And so our new problem will say volume times density equals, volumes canceled, equals mass. But we need to get the volume by itself. So now we're going to have to divide both sides. So now we're going to divide by density. Probably should have just used letters to make this faster. Divide both sides by density. So density cancels out on this side. And we're left with volume equals mass over density. Or to write it more efficiently, volume equals mass over density. So now we can use that and we can put in the pieces that we have. All right, so we want our volume. We have our mass, which is 1.32 kilograms. And, we have another problem. This is in grams per milliliters. Oh no, that means we can't start with kilograms. We're going to have to start by changing kilograms to grams. So we're going to pause and we're going to do 1.32 kilograms. And we're going to use a conversion factor so that we can change that into grams. So if I have written somewhere on here what my conversion factor is, let me erase this because that's where I'm going to put my conversion factor. That's great. If I haven't, this is a good time to write it. Grams to kilograms. Kilograms is bigger, so there's my 1, and there are 1,000 grams in a kilogram. So I'm going to write the numbers in the correct place, and then I'm going to solve for that. It's times 1,000. There are 3 zeros, so it's like this gets to move 1, 2, 3 decimal places. So my answer is 1,320 grams. This has 3 significant digits in it, and so does my final answer right here. And so we don't have to change anything about it. Now we're ready to use the formula that we converted and put in our numbers because we now have grams and that matches grams per milliliters. All right, so let's see if I can move this so you can see everything. All right, let's change pen colors. All right, so volume equals mass over density, and our mass is in grams and our density is in grams per milliliter. And that may be a little confusing why the grams cancel, but remember when you have a fraction that's really like you're dividing. I'm going to come over here to the side for a second so I can explain that. So mass over density is the same as saying mass divided by density. So our units are grams divided by grams per milliliters. So remember when you did fractions in elementary school, when you're trying to divide a fraction, you can say times the reciprocal and flip over the fraction. And then notice that the grams would cancel and you'd be left with just milliliters, which is good because that's the volume that we want. So this is just a little kind of side note to explain that the units really will cancel to be just the ones that we want at the end. Okay, back to our problem. So let's put in our numbers. So our mass is 1,320 grams. Our density is 4.9 grams per milliliter. And on the bottom of the fraction, this gram and this gram will cancel, and the milliliter will become our unit on the top, because it's like on the bottom of a fraction on the bottom of a fraction. And two bottoms of a fraction kind of cancel out to make a not a fraction. All right, so I'm going to just put this into my calculator. 1320 divided by 4.9. And I get a really, really long number, but we don't need that many digits. Let's look at what we do need. We're dividing. So what we care about is how many significant digits we have. We have 3 in 1,320, and we have 2 in 4.9. That means our final answer can only have 2 significant digits or 2 significant figures. Our answer is 269 point blah, 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 blah. So that means only these first 2 can be significant. We have to round to the tens place in this. Obviously, we're going to have a ones place because we can't just not have a ones place. But the ones place is going to be a 0. And there's not going to be a decimal after it, so that it's obvious that it's not a significant figure. So if we only want to keep the 2 and the 6, we need to look and see what comes after the 6. It's a 9, which means it's going to round up. So that becomes 270. What we're doing is we're rounding this number up to the tens place. So 269 rounds up to 270 milliliters. And that's our final answer for the volume. It did not ask for a specific unit, so we can just leave it in the units that we have right now, the milliliters. It could have asked us to complicate things and put it in liters or something like that, but thankfully it did not, because I think we had enough conversion going on with this problem. All right, I'm going to back up a little bit just in case you want to pause and look through our work. All right, good luck working on this one in the comprehension checks.